So, have you ever had this happen? You build an amazing machine learning model. It works perfectly in the lab. But then you watch it just mysteriously fail out in the real world. Well, there's often a silent killer at work, a sneaky problem that can take down even the best models over time. Today, we're going to put on our detective hats and investigate this whole thing. And the first question we have to ask is a big one.
Right? This is the core of the mystery. It's so frustrating for any data scientist. You test it, you validate it, you push it to production, and then, boom. Slowly but surely, its performance just drops off a cliff. And the reason, most of the time, is that the world simply didn't stand still.
And look, the consequences here are not just some academic problem. When these models fail, the stakes are incredibly high. We're talking about real-world impact, from massive financial losses to really dangerous outcomes in places like healthcare or autonomous vehicles. So this isn't just a bug. It's a critical vulnerability.
Okay, so it's time to pull back the curtain and formally identify our prime suspect. In this first part of our investigation, we are going to unmask this silent killer of our machine learning models. And there it is. The culprit has a name: data drift. The key thing to get here is that the model itself hasn't changed, but the world around it absolutely has. The data being fed into the model today is just fundamentally different from the data it was trained on. You know, it's like a brilliant detective who was trained on 1940s crime cases trying to solve a cybercrime today. The tools and the rules just don't apply anymore. Here is a perfect, clear-cut example of how this plays out. Imagine you trained a model to predict buying habits, and it was trained on customers who were between 20 and 45 years old. But hey, time passes and your user base shifts. Now most of your customers are in the 50 to 70 range. Your model is completely out of its depth. It has literally never seen these patterns before, so of course, its performance is going to plummet. So what are the motives? Why does data drift even happen? Well, the reasons are all around us all the time. Customer tastes change, right? Seasonal events like the holidays totally alter buying patterns. And huge external events like a global pandemic or a recession can completely upend economic behavior. Sometimes it's even an internal problem, like a bug in how you're collecting your data. Our culprit here also wears a few different disguises. The most common one is what we've been talking about, data drift, where the input features, the X variables, change. But there's also something else called concept drift. Now this one is way more subtle. It's when the very meaning of what you're trying to predict changes. A classic example is fraud detection. What counts as fraud is a moving target because the bad guys are always inventing new schemes. Okay, so we've identified our suspect. Now for the fun part. How do we catch it in the act? That brings us to our forensic analysis, the techniques that data scientists use to actually detect drift. So, the first set of tools in our forensic kit are statistical tests. These are basically mathematical methods to compare two piles of data. In our case, the training data versus the live current data. Each test has its specialty, right? Like the Kolmogorov Smirnov test is great for comparing distributions, chi-square handles categorical data. But the one you're going to hear about most in the industry is the Population Stability Index, or PSI. That's kind of the gold standard. And this is brilliant because it shows you exactly how to read the evidence from that PSI test. It gives you a single number, and based on that score, you have a super clear action plan. If it's below 0.1, you're good to go, no drift. Between 0.1 and 0.25, okay, that's a yellow flag. Keep an eye on it. But if that PSI score climbs above 0.25, the alarm bell should be ringing. That's a sign of severe drift, and it means it's time to retrain your model, like right now. Of course, not all the evidence is going to be numbers. Sometimes the most powerful forensic tool you have is, well, your own eyes. Just plotting the distribution of a feature from your training data and layering it right on top of the distribution from your current data is often the fastest, most intuitive way to see that something has changed. Now, running these tests by hand is one thing, but in the real world, you absolutely need to automate your surveillance. So let's look at the specific tools and platforms that modern data detectives use to monitor for drift 24/7. The modern detectives toolkit is packed with some seriously powerful software. There's this whole ecosystem of MLOps platforms designed just for this. You've got great open source frameworks like Evidently AI or Selden's Alibi Detect, which are fantastic for teams that want deep control. Then you've got the big cloud providers, like AWS with its SageMaker Data Quality Monitor, which offer this as a built-in service. These tools are what turn that manual forensic work into a 24/7 automated security system for your models.
So we know who the culprit is and we know how to catch them. The final piece of this puzzle is building a defense. What's the action plan for when you detect drift? And more importantly, how do you prevent these crimes from happening again?
Once an alert gets triggered, you need a clear, repeatable response plan. The most common action, of course, is to retrain the model on new, more relevant data. But sometimes it's more complicated. You might need to collect different kinds of data or fix how a feature is being calculated. And in really high-stakes situations, you might just have to pause the automation and get a human to review the predictions. And this right here is the rulebook for your long-term defense. This is how you go from being reactive to being proactive. It's all about building a solid system, automating your analysis, setting clear thresholds for alerts, monitoring everything from inputs to outputs, and using cool techniques like shadow deployment to test new models on live data safely before they go into production.
I love this quote because it really gets to the heart of the matter. It's a total mindset shift. A model's performance degrading isn't a sign that the model was poorly built. More often than not, it's a sign that the model was doing its job perfectly in a world that just doesn't exist anymore. So, after a big investigation, what's the final verdict on data drift? Let's bring all the evidence together and sum up what we've learned about this quiet but incredibly powerful force in machine learning. And really, it all just comes down to this. The idea that you can build a model, deploy it, and then just walk away, it's a total fantasy. The world is always changing, which means our data is always changing. So the only way to build reliable, robust, and safe AI systems is through constant, continuous monitoring. It's not some optional add-on, it's a fundamental necessity.